So this is my invention called Earthlight here, and basically you've got three main parts, actually four main parts, but I'll show you the three main ones. You got your anode, which is your negative. You got your cathode, which is your positive. You've got waterproof housing right there, which simply attaches to this stake, so you can put it on display and read if the LED is on or not. You don't necessarily need the stake, so that's not really critical. So inside that housing is a special booster circuit, which basically makes the 0.75 to 1.5 volts that this produces, and it boosts it up to 3 volts in order to light a 3-volt LED. And there are no batteries whatsoever. It's 100% powered by soil, and it's a great, really simple instance of the work that microbial fuel cells can do. The problem being is that they're usually complicated, bulky, and expensive to make. This pretty much brings the cost of a microbial fuel cell down to nothing, and you can put it in your pocket and take it with you. So I've just loaded that up with some soil here. It's not super packed in there, it's just tight enough to stay in there. Luckily the soil's good and moist, so it'll stay. And I'm just going to insert this down into the middle of the soil there. Also, I'm going to recompact some of this. Yeah, and there's a chance that the soil sucks because it's just been a dry pot sitting out in the sun for months. It barely works. So yeah, this is what I would call shit soil. Let's go find some good soil. We found shitty soil.
Where at?
This pot.
Oh yeah, that's crazy dead.
Yeah, this soil sucks.
Yeah, it has no mycorrhiza in it.
No mycorrhiza, no nothing. I wouldn't have known that. I thought it was good, but Earthlight told me it's shit.
Well, it's become hydrophobic because it
Right.
left out in the sun in a hot pot,
Right.
and it dried out, and all the mycorrhiza turned to spores and dipped.
So we found some dead soil that we wouldn't know was dead otherwise, because it looks, you know, fairly dark, but apparently it's super hydrophobic, has no microbes in it. I kind of got the story with this soil. I didn't know we had bad soil on this property, but that's okay because we've got this compost tea right here, which is it's made from found microbes on the property from various sources that we identified as microbe rich. We put those in a mesh bag. We put it in a solution of water with a couple tablespoons of molasses, and we've been aerating it with this pump here for about 2 days now. We've got one head of the pump low in the bucket, one of them high, to create a circulation. This doesn't put air into the water, it actually just creates air bubbles which circulate through the circulation. And in a couple of days you've got this really nice dark colored tea here, and we've looked at this under the microscope and it's just loaded with diverse microbes. So for this I honestly don't necessarily need to put it down into the soil, but I'm going to because I'm adding the compost tea to the area. You can also just test this by pouring the water into the cell on its own, but I'm gonna put this like this. I have a feeling that this tea is good enough where it should work in the side-by-side long-term setup. So we're gonna put this rod next to our cylinder as opposed to inside of it. Make sure that the soil's pretty compact between the two of those. Did I bring my stake? I don't think I have the stake, but that's okay. We still have the light. So let's see if we can get this the soil to do anything again. Let's see. It's a little bit far. But yeah, that didn't do anything before. It definitely wouldn't have worked in the side-by-side long-term setup. And you can see that's fairly bright. I mean, even in, you know, broad daylight. So, bam. Good compost added to poor soil will only lead to good soil. So that's Earthlight winning and helping you win.